Another way of solving a quadratic equation is by completing the square. So in order for us to complete the square, my first step is making sure that my a value is equal to 1. If my a value is not equal to 1, I need to make sure that I divide the whole equation by a. So now in this situation, my a value is equal to 1. So I can proceed to my step 2. My step 2 is taking the c value or the constant value from the equation and moving it to the other side. So move the constant to the right side of the equation. So here I have x squared minus 3x minus 5 is equal to 0. So my constant here is the 5, so I add 5 to both sides. After I do this step, next step is taking my b term. So take the b term and multiply it by 1/2. And after I multiply it by 1/2, I would square the results. Square the results. So here my b value is equal to -3. So what I do is I take that b value, I multiply it by 1/2. So 1/2 times -3. And then I square it. So here the 1/2 gives me -3/2 square, and that should equal to 9/4. So after I do this step, now my next step, which is step 4, is add the results from step 3 to both sides of the equation. From step 3 to both side of the equation. So here I will take my equation, which is x squared minus 3x equal to 5, and I would add what I got from step 3, which is 9/4 to both sides. So notice right here, my left-hand side, I would be able to get a perfect factor, and my factor would be x minus 3/2. Now the 3/2, the -3/2, we get it from whatever we multiply the b value by. So now here my b value is -3. I multiplied it by 1/2. So whatever your result, before you square the results from step 3, that is what goes on with your first factor. That's where you write with your factor here. So now here 5 plus 9 over 4 would give you 29/4. Now from here, I'm going to use the square root property. I'm going to square root both sides. Square rooting both sides would give you x minus 3/2 is equal to the square root of 9/24. I'm going to use the square root property of a rational number, and that allows me to square root the numerator and square root the denominator separately. Now remember, the square root gives you positive and negative answers. So now here, x minus 3/2 is equal to plus or minus square root of 29. Now the square root of 4 is 2. Now my next step is adding the 3/2 to both sides. That gives me 3/2 plus or minus square root of 29/2. Since I have the same denominators, I can just add the numerator. So x is equal to 3 plus or minus square root of 29/2. I can separate these solutions and obtain 3 plus square root of 29/2. And x is equal to 3 minus square root of 29/2. And these are my x-intercepts of this function. In this example, I am given the general equation of a quadratic equation, which is ax squared plus bx plus c. And I am gonna solve for my x values in this equation using completing the square. So now here I'm gonna assume that my a value is not 1. Since I'm not given a value for a, I can't assume that it's 1, so I will assume it's not 1, and I will be dividing my a value for both sides. I'm going to divide both sides of the equation by the a value. And now here, I am going to separate this. I'm going to have ax squared over a plus b over ax plus c over a. And 0 divided by a is just 0. Now, a divided by a is just 1. So I would have x squared plus b over a x plus c over a is equal to 0. Now, my next step to completing the square, I would take the constant of the equation and move it to the right-hand side of the equation. Now, my constant here is c over a. So that would give me x squared plus b over ax is equal to negative c over a. So subtracting c over a from both sides would obtain this equation. Now, my next step is taking the b value, where here my b value is equal to b over a, and I would multiply that term by 1/2. So multiplying that by 1/2 gives me b over 2a, and then squaring the result. So now from here, my next step is adding the results from my previous step, which is the results from multiplying by 1/2 and squaring the b value. So here I would have x squared plus b over a x plus b over 2a squared is equal to negative c over a plus b over 2a squared. Now here, my left-hand side of the equation would give me a square, a factor of a square. So now here I would have x plus b over 2a squared. Remember, this factor right here, we obtain it from multiplying the b value by 1/2. Now, on the other side of the equation, I am gonna get rid of the parentheses. So now here I would have plus b squared over 4a squared. And now from here, in order for me to add these two terms, I need a like terms. So now from here, I would have to multiply this by the least common denominator. So in order to obtain that, I would have to multiply the negative c over a by 4a. Whatever I do to the bottom, I need to do to the top, so I multiply that by 4a. Multiplying that by 4a would give me x plus b over 2a squared is equal to negative 4a times c all over 4a squared plus b squared over 4a squared. Now, since I have the same denominators, I can add them together. Squared is equal to negative 4ac plus b squared all over 4a squared. Now I'm solving for my x term in here. I'm solving for my x-intercept. So now here I'm going to use the square root property. So square rooting both sides would give me x plus b over 2a is equal. Now the square root property of a rational number tells me I can square root the top part and I can square root the bottom part. So on the top, I'm just going to rearrange the top. So I can do b squared minus 4ac all over the square root of 4a squared. Now notice that the bottom right here, I'm going to finish my work here. So x plus b over 2a is equal. Now I can't do anything on the top, so I'm going to leave it as it is. B squared minus 4ac. However, the bottom would give me a 2a. Now remember, the square root gives you a positive and a negative value. So now here my next step is I am gonna subtract b over 2a from both sides. So that gives me x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Since these have the same denominator, I can just rewrite it as negative b plus or minus square root of b squared minus 4ac all over 2a. So notice right here from my results of completing the square root of a generalized quadratic equation, I am able to obtain a formula that we can always use to solve for the x-intercepts of a quadratic equation, and what we call the quadratic formula.